Okay, right. Now let us go through hey, have I shared screen? Yes, I did. Okay. We'll go through tutorial 15 first because I know we didn't go through 15, right? It's supposed to be covered last week. We actually went through 16. So let's just go through this. Casey wanted to open the metal lid of the glass jar. She placed the metal lid of the jar in a basin of water. After some time, she still could not open the metal lid of the jar. What should she do? So of course, it is to put the whole jar into replace the water with hot water, because when you put hot water, okay, if this is hot water, then what will happen is that the metal lid will gain heat and expand, right? So the moment it gains heat and expand, that's when it's easy for us to open a glass jar. So the answer is D. Are we okay? All right, I'm going to move on very quickly because we still have to cover tutorial 16. Okay, Eileen, notice that there are gaps in the train tracks as shown. The purpose of the gaps is of course, the purpose of the gaps is to allow for expansion, right? Because you want to have some allowance. So in case it expands bigger, at least there is room for expansion. If there's no room for expansion, then the train tracks will just buckle up. So the answer is B. Okay. Okay. Question 3, water can change from one state to another through different processes A, B, C, and D. Which of the following about the processes is correct? Now, we are talking about heat gain and heat loss, okay? So actually, from solid to liquid, the process is actually melting. Oh, let me change the color. Okay, solid to liquid, the process is melting. Liquid to gas, the process is either boiling or evaporation. Gas to liquid is condensation. Liquid to solid is freezing. Okay, so in this case, if you want for it to melt, of course, the solid ice, for example, has to gain heat. When it gains heat, it will be able to melt. Okay, so the processes that involves heat gain will be A and B, which is this. Then the process of heat loss will be C and D. Okay, so the answer is C. Any questions? Aber, okay? Aber is wearing sunglasses. I can see his eyes. Okay, all right, let's move on. Now, Regina placed equal amounts of ice cubes into 4 cups, P, Q, R, and S, of the same size. The cups were made of different materials. The time taken for the ice cubes in each cup to melt completely is shown. Which cup should Regina use to serve hot tea so that the tea would cool down the slowest? Now, whenever you want something to cool down the slowest, or you don't want it to lose heat the slowest, basically you want to keep food cold. This one means you want to cool down the slowest, means you want to keep the food as cold as possible, right? You don't want it to lose heat. Okay, you don't want it to lose heat the slowest as well. So that is making sure that you are keeping your food hot. Okay, right. I might have to remove that because your annotation will not be safe actually. Yeah, so I think I will annotate instead. Okay, but thank you so much for having the intention to try the question. Yeah. Okay, so if you want to keep food hot or you want to keep food cold, right? It's the same concept. Basically, for both scenarios, you want to use a poor conductor of heat. Why? Okay, why do we want to use a poor conductor of heat to keep food hot and cold? Because we do not want, let's say for example with the ice cream, Okay, we put the ice cream inside a container that is a poor conductor of heat. Then we do not want to lose heat to the surrounding fast, right? We want the ice cream to be cold. So we want a poor conductor of heat, because if heat is conducted very fast to the ice cream will gain heat and melt, which is not what we want. Okay, and why do we use poor conductor of heat when we want to keep food hot? For example, you have a flask of soup, hot soup. You want it to be hot. So you don't want the heat to be lost from the soup to the surroundings so fast. That's why when we keep soup that are hot, we put it inside the thermoflask or something, right? Because the thermoflask has a layer of vacuum in them, and vacuum is a poor conductor of heat. So it does not lose heat so fast, and then the soup will be kept hot for a long time. Okay, so going back to this question, the time, okay, the results actually show time taken for the ice cubes to melt completely. So for this one, of course, the one that melts the slowest, okay, which is R, is the poorest conductor. Right? So it is the poorest conductor of heat. Therefore, the answer is D. Yes, I see Ariano celebrating. Very good. Okay, so that's correct. Yeah. Okay. Now this question is easy. Which one is not a source of heat? Of course, the sun is, because the sun is the main source of heat. Okay. Lighted bulb is, cotton shirt is not, candle flame is. So the answer is C. This one is quite straightforward. Yeah. Okay. Next question. Ronald places a metal rod in a cup of hot water. The metal rod becomes hotter after a while. What explains this? So always ask yourself, where is the hotter region? Of course, the hotter region is the hot water, right? So heat will always, okay, I think the underlying concept is that heat will always travel from a hotter region to a colder region, okay? So the hotter region is the cup of hot water. The heat will be conducted to the metal rod, right? So the rod will gain heat from the hot water. So that's correct. Answer is A. Okay. The cup will lose heat to the hot water. That's wrong. This one should be gains heat from. Because the hot water is the hottest region here. So of course, heat will travel from the hot water to the metal rod as well as to the cup. Okay. The rod loses heat to the hot water. This is wrong as well. This one should be gains heat from. Okay, and the last one, the hot water gains heat from the rod. The hot water actually loses heat because the hot water is the hottest region. It loses heat to the rod. So answer is A. Okay, now next one, Peter. Peter put the same amount of cold water at 10 degrees Celsius into a styrofoam cup and a plastic vase. When he touched them, his hands felt that the plastic vase was colder than the styrofoam cup. Okay, so which of the following explains why Peter's hands felt that the plastic vase was colder than the styrofoam cup? Now, mind you, the temperature is the same. Okay, both are cold water at 10, right? Oh dear, Abir, where are you? You suddenly go missing. You go to the toilet or something, Abir? Okay, great. Abir is back. Okay. Okay, so they are the same temperature. The water is the same temperature. So why is it that when Peter hold the two of them, the plastic vase was colder? That's the reason is because plastic vase conducted heat faster. And when it conducts heat faster, ask yourself, where's the hotter region? Is it the cold water or is it the hands?
Hands.
Very good. Okay. So the hotter region is actually the hands, which means the heat will travel from the hands to the other parts of the experiment. So if let's say the hands felt colder for plastic, it means that plastic is a better conductor. Why? Because the heat from the hand is quickly transferred to the plastic vase. Okay, so plastic vase is actually a better conductor of heat than the styrofoam cup. So the answer is actually B. So the plastic vase gain heat slower. This is wrong. Actually, it gains heat faster. Okay. C, statement C, why is it wrong? The plastic vase had a lower temperature. That is wrong. It has the same temperature, right? It's both at 10 degrees. So it has the same temperature as the styrofoam cup. The plastic vase had more contact with the hand. That's not true as well. I think it's quite fair, right? They are supposed to have the same contact with the cup for both experiments. Yeah. Okay. Now, next question, study the diagrams below. Which of the following beakers contain water with the greatest amount of heat? Okay. Anyone wants to volunteer for this? This one is actually quite straightforward. Yes, Abir?
P.
P. Is it P? P for penguin? Okay, let's have a look, yeah. Greatest amount of heat is what we want to look for. Greatest amount of heat. Now, these two are 90 degrees.
Oh no, not P. It is Q.
Yes, it's Q because the temperature is the most as well as the volume is the most. The volume actually affects the amount of heat energy in a substance. Okay, so that's B. Answer is B. Good. Any questions so far? Okay. Now, number 9, Sam attached 3 thumbtacks to a metal rod as shown. He then heated at point X. So which one shows the correct order in which the thumbtacks fell? Of course, it's the one closest to the heat first, right? So R first. Then, oh, actually, we only have one answer. R, then Q, then P. Okay, great. Well done. Number 10. Bob placed a packet of cold orange juice in a basin of hot water. Which of the following would take place? The water would decrease in temperature. The orange juice would lose heat to the water. The water will lose heat to the orange juice will increase in temperature. Okay, now always determine where's the hotter region. Of course, it's the hot water, right? Hotter region is the hot water. Then, of course, this is the colder region. That means the heat will travel from the hot water to the orange juice. The water will decrease in temperature. That is true because when heat is lost, okay, when the heat is transferred from the hot water, it will actually decrease in temperature. Okay, now option B, the orange juice would lose heat to the water. That is wrong. It should be, it would gain heat from. Right, because the orange juice is colder region, so it will gain heat from the hotter region, which is the hot water. The water will lose heat. This is correct because, like I said, the water is the hotter region. The orange juice will increase in temperature. That's correct. So the answer is B. A, C, and D. Okay? Yeah? Okay, actually, we have an activity. Let us get started with that. Let me send you the link, okay? Give me a while. Where is it? Have you played Wordle before? Yes?